Welcome back, friends. My name is Satyajit Sahu, and today we are going to see an important topic, that is loss of pre-stress due to elastic deformation or elastic shortening of concrete. Okay, so many students have already given the GATE 2023, right? And the results are already out. Some students might be planning for 2024. Yes, many students will be fresh candidates who will be starting their journey for the GATE 2024. Yes, you might be in third year, you might be in fourth year, you might be a pass out, right? So, my name is Satyajit Sahu, and now on BYJU'S exam prep, we will be having a lot of sessions for GATE 2024. Already a lot of sessions have started. Yes. So, many students who are knowing me from before. Uh, I was not taking classes for 2 months. Yes, I was on a break. Yes, but the break is over, right? The break is over, and finally, I am going to take a lot of classes on this particular channel, that is BYJU'S Exam Prep, Civil, Mechanical, and XE channel. So, if you are seeing me for the first time, I'll request you that please subscribe to the channel so that you can see the other lectures also. Yes, and from now we'll be taking a lot of lectures, okay, live on YouTube. Okay, so many students already know me. Those who don't know me, a short introduction about myself. My name is Satyajit Sahu. I have 10 plus years of experience, okay, in GATE and ESE domain. Yes, welcome Jay, Survi, Nikki, and Juhi. Okay, warm welcome to all, right? And I have done my BTech and MTech from IIT Kharagpur, and other credentials are also mentioned in the slide. You can go through that. One of the important points is that I cover the whole civil engineering. मैं civil engineering पूरा ही पढ़ाता हूँ. Yes. तो आने वाले टाइम पे हम बहुत सारी क्लासेस लेने वाले हैं सिविल इंजीनियरिंग में. So today's class I will be using both English and Hindi. It will be a mixed lecture. Yes. तो mixed lecture करके पढ़ाएंगे. Yes. हिंदी भी पढ़ेंगे, इंग्लिश भी पढ़ेंगे. Yes. Become comfortable in both the languages. Right. So let us start today's class without any further delay. So today's class is on what? Loss of pre-stress due to elastic shortening of concrete. Due to elastic shortening of concrete, or I can say deformation of concrete. So क्या कहेंगे हम लोग? इसको हम कहेंगे shortening. This deformation is what? It is shortening or deformation. Same thing here in this case, right? So I will again tell that this lecture will be beneficial for students who have a basic idea of your pre-stressed concrete. Yes, so students, I will be telling you that this lecture will be more helpful for students who have prepared for 2023 or 22 or 21 and further years. Yes, or if you have covered the basics of pre-stressed concrete from your college, okay, that will be very helpful. Let us start the lecture without any further delay, right? Okay. Now you see, this is a concrete beam. This is what? This is a concrete beam. This is a concrete beam. In this concrete beam, suppose we are doing a pre-stressing, right? And suppose the pre-stressing I am doing using a tendon, right? We all know that we do the pre-stressing using a tendon, right? Suppose a tendon is something like this. The shape of a tendon is parabolic, suppose. And suppose a tendon is something like this, right? So what we do to the tendon? We apply a tension to the tendon, right? What we do? We apply a tension force. What is the tension force? This is known as what? The pre-tensioning force. Welcome to all the enthusiastic participants, and also welcome to all the students who are watching this lecture live. Okay. So pre-tensioning force. This is known as what? Pre-tensioning force in tendon. So what we do? We apply tension to this tendon, and this tendon is made of what? Please write in the comment section, all the students who are watching this lecture. This tendon is made of what? This is known as tendon. This is known as also cable, right? And this is also known as a combination of wires. So this tendon, cable or wires, they are made up of what? Can somebody write in the comment section? ये जो tendon है, cable है या wires है, ये किससे बना होता है? From which material it is prepared? ये किससे बना होता है? ये टेंडन, केबल, वायर्स जो हम सुनते हैं कि जिसे हम प्री स्ट्रेसिंग कर रहे हैं, वी आर डूइंग द प्री स्ट्रेसिंग, दैट इज मेड अप ऑफ व्हिच मटेरियल? यू कैन राइट इन द कमेंट सेक्शन. आई विल वेट फॉर आंसर. Okay, nobody is writing. Okay, they will write. Okay, some students are waiting. Okay, some students had written steel. Yes, this cable, tendon or wires which we see, cable, tendon or wires which we are seeing or writing here, it is made up of steel. Steel, right? So basically steel cables. So when you apply tension to this particular, this is what? Pre-tensioning force. So when you apply tension to this particular concrete beam, no, the tendon, so what happens? There is compression acting on the concrete, equal and opposite reaction, right? So we are applying tension to what? We are applying tension to steel, the cable which is made up of steel, and what is happening? There is compression in concrete. There is compression in concrete. Okay, so there is what? Equal and opposite compressive force. Equal and opposite compressive force acting on the concrete. So some student writing, Chakri is writing, thanks for coming back. I never went anywhere. I was having a vacation. The vacation is over. You can see that my face has brightened a bit. Yes. Yes. And I've become little thick also. Little motu, okay, because I had a nice break. So now I will be taking a lot of classes and we will enjoy this comeback, okay. So do you see there? So there is what? Compression acting on the, there is compression acting on the concrete. That is what? Compression acting on the concrete. So what will happen? Due to this compression, there will be compression or deformation or shortening of concrete. Yes, you can see what is happening. What is happening? Due to this force P, due to this force P, there is what? There is shortening of concrete, right? You can see there is deformation, right? Here deformation, here deformation. This is known as what? This is shortening of concrete. This is what? Shortening or deformation of concrete. And it is elastic deformation. It is what? Elastic shortening or elastic deformation. So due to this elastic deformation, there will be pre-stress loss in the tendon. Yes, you see, concrete was like this. Tendon was also attached to this. So when concrete becomes like this, what will happen? The tendons will be loosened, right? अगर हिंदी में बोलेंगे तो क्या बोलेंगे? तो concrete था ऐसा था, ठीक है ना? Concrete beam ऐसा था. अगर आप concrete beam को shorten कर दोगे, कंक्रीट बीम शॉर्टन हो गया, यस, ड्यू टू डिफॉर्मेशन कंक्रीट शॉर्टन हो गया, तो तुम्हारा जो टेंडन है वो ढीला पड़ जाएगा ना, यस और नो. आपका कंक्रीट ऐसा था, यस, कंक्रीट क्या हुआ? शॉर्टन हो गया. अगर कंक्रीट शॉर्टन हो गया तो क्या होगा? तो स्टील जो टेंडन उसके साथ अटैच है वो क्या हो गया? ढीला हो गया. अगर स्टील ढीला हो गया इसका मतलब क्या है? इसका मतलब ये है कि उसमें टेंशन कम हो गया. टेंशन कम हुआ मतलब क्या? लॉस ऑफ प्री स्ट्रेस. That is known as what? Loss of pre-stress. So we will repeat in English. So in repeat in English, what happens? Due to compression of concrete, the tendon loosens up, or I can say there will be loss of pre-tension force in the tendon, and this loss is known as what? Pre-stress loss due to elastic deformation or shortening of concrete. Understood? So now let us find out the expression then. Yes, so I told that okay, we are having some loss. So what is the value of that loss? So pre-stress loss, so pre-stress loss due to elastic shortening, due to what? Due to elastic shortening of concrete, due to elastic shortening of concrete, the formula is given by M into FC. What are these terms? We'll understand slowly. No hurry. No hurry. M into FC. We'll understand the terms. But let us see the definition again. जो definition हमने पढ़ा था उसको एक बार देख लेते हैं. क्या लिखा हुआ है? Pre-stress loss due to elastic deformation of concrete. Yes, is a phenomenon which occurs in pre-stress tendons when concrete undergoes elastic deformation under the action of pre-stressing force. जो हमने समझा था उसी को खाली इंग्लिश में लिख दिया है. Understood? Whatever understood, that only is what? Reframed here. Yes, that only is reframed here. Now I told that the formula is what? M into Fc. The formula is what? M into Fc. This loss is what? M into Fc. Now what is your M? Your M is your modular ratio. What is your M? M is your modular ratio. Modular ratio, it's ratio. Ratio of what? Ratio of modulus of elasticity of two terms. What? Modulus of elasticity of steel and modulus of elasticity of concrete. This is what? Modular ratio. Modulus of elasticity of what? This is what? This is of steel and this is of concrete. Modular ratio. This is the first term, M. Now what is Fc? What is Fc? You see, this is your lengthwise diagram of the beam. This is the lengthwise diagram of the beam. You see, this is L length. This is the lengthwise diagram of the beam, right? Suppose I am having a tendon here. I am having a straight tendon here. I'll draw a straight tendon, okay? I am having a straight tendon like this. I am having a straight tendon like this. Okay, this is a straight tendon. This is what? A straight tendon. सीधा टेंडन लगा दिया है, ठीक है ना? सीधा टेंडन लगा दिया है. This will be the eccentricity of the tendon. This will be eccentricity of the tendon. Now suppose this beam is a rectangular beam. Suppose this beam is a rectangular beam. अगर ये rectangular beam होगा, so if I see from this side, if this is a rectangular beam and I see from this side, it will look something like this, ना? ऐसा दिखेगा ना? Yes, it will look something like this, na? Yes, you see? See? Yes, it looks something like this. Yes. So this is the beam with dimension what? Your B and D. Okay, the dimensions B and D. And you see, this is the tendon. This is the tendon. This is the tendon. Right? And you see, this is the neutral axis. This is the neutral axis. And ladies and gentlemen, what will be this? This will be the eccentricity E. This is the eccentricity E. Very good, very nice. Now, suppose sigma S is the initial. It is the initial pre-stress. It is the initial pre-stress. Stress means what? What will be the unit? It will be Newton per mm square. Newton per mm square. Now, suppose the area of tendon is AS. It is what? It is your area of tendon. It is your area of tendon. That is what? Suppose in mm square. Right? Mm square. Now, what will be the pre-stressing force then? What will be the initial? What will be the initial pre-stressing force? What will be the initial pre-stressing force? The initial pre-stressing force. Force is what? Stress into area. What will be the force? Force will be stress into area. Very easy, very easy, very easy. Now coming to this Fc term. What is this Fc? Fc is the stress in concrete. Fc is what? Fc is the stress in concrete at level of tendon. It is the stress in concrete at level of tendon. How to find this? That is very easy. The formula is the total pre-stressing force P by area A plus the pre-stressing force P into E square by I. Now how to understand this formula better? I'll give you very easy now. This is P. P what we told? P को क्या बोला हमने? P को हमने बोला प्री स्ट्रेसिंग फोर्स. कैसे निकालना है? देख लिया, स्ट्रेस इनटू एरिया करके निकाल लेना है. Yes. Now what is this area? This is the area of concrete. This is the area of concrete, not the area of tendon. It is what? Area of concrete. Because you are finding the stress at level of tendon, but where? The stress in concrete. इसका मतलब क्या है? इसका मतलब ये है कि ये आपका टेंडन है ना, ये टेंडन के लेवल पे कितना स्ट्रेस है, किसमें? कंक्रीट में. यस, यू सी हियर कंक्रीट इज देयर ना, हियर 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 कंक्रीट इज देयर ना, राइट? सो व्हाट इज द stress in concrete at level of tendon? That is your Fc. So here what I am dividing? I am dividing the area of concrete. Now I is what? It is the moment of inertia. What is I? I is the moment of inertia. I is the moment of inertia where? Where? Of what? Of, not where, of what? Of the cross section. Of cross section, which cross section? Which cross section? Cross section of concrete. Cross section of concrete. Now, area of concrete, it's a rectangular, normally beams are rectangular, right? So what will be A? A will be B into D, right? A will be B into D, right? Yes, good evening civil flow. And then what will be the moment of inertia? It's rectangular. That means what? BD cube by 12. Very easy, right? Very easy. And E is your eccentricity. So nicely you can find out FC. Yes, nicely you can find out FC. Multiply with the modular ratio M and you get this loss. Let us solve one question then. Let us solve one question then without any further. Question solve करते हैं, ठीक है ना? Question solve करते हैं, मजा आएगा फिर, right? So question देखिए, क्या लिखा हुआ है? Question देखिए. How are you? Very nice. You can see I am very nice. Yes. So question solve करते हैं, okay? Let us solve question, okay? अब क्वेश्चन में सबसे पहला काम क्या करना है? Whenever you solve the question, first thing what you should do, you should write down what all things are given here. Let us write what all things are given in this question. क्या लिखा हुआ है? Pre-tensioned beam. क्या लिखा है? Pre-tensioned concrete beam. Cross section is 150 mm wide and 300 mm deep. Is pre-stressed by what? 8-7 mm dia wires. What is the meaning of this? Welcome, welcome, civil flow. Keep attending. We'll have more sessions. Now suppose this is your beam. So this is given how much? 150 and this is given your 300. Now there is a tendon at how much eccentricity? Eccentricity is not given. It is given that this particular tendon, which is comprising of many wires, is at how much distance? It is at distance of your 100 mm from soffit. What is the meaning of soffit? What is the meaning of soffit? Soffit means bottom. Soffit means what? Bottom. Bottom, or I can say soffit. Now tell me what will be the eccentricity then? Tell me what is the eccentricity then? If this is given, what is the eccentricity? Tell me. What will be, ladies and gentlemen, eccentricity in this question? Ladies and gentlemen, what will be the eccentricity in this question? इस क्वेश्चन में आपका eccentricity कितना आएगा? बताइए, बताइए, बताइए कितना आएगा, बताइए. Common sense. Eccentricity is always from where? From the neutral axis. हमेशा आपका eccentricity neutral axis से ही आएगा. Always your eccentricity is from neutral axis, right? So देखिए ये 300 का है तो ये आधा हो जाएगा. It will be half. This will be half, so it will be 150, and this is given what? 100. So obviously your eccentricity is how much? 150 minus 100. That is how much? That is your 50 mm. Yes. So we found our eccentricity. Very nice, very nice. Now the next aim is what? To find out the pre-stressing force, because in the formula P is there. Now you see the wires are tensioned to a stress of 1100. This is the initial stress given, right? It is given how much? 1100 Newton per mm square, or I can say 1100 MPa, or I can say 1100 MPa. Very nice. Now to find out the area of steel, how to find out area of steel? You see this tendon is comprising of how many wires? 8 wires are there. 1, 2, 3, 4, 5, 6, 7, 8 wires are there. Yes, 8 wires are there in this tendon. Okay, in this tendon 8 wires are there, and each wire is 7 mm. Each wire is 7 mm. अगर एक वायर का डायमीटर 7 mm है तो उसका एरिया कितना हो जाएगा? Pi by 4 into 7 square. Yes, pi by 4 d square. That is how we find out the area of a circle, right? Because circular wires. Now there are how many wires? 8 wires. I'll multiply what? 8 and I'll get the total area of the steel. So tell me what is the total area of steel? Calculate and tell me. चलो 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 जल्दी बताओ कितना है आपका एरिया ऑफ स्टील कितना आ रहा है? ये आपका आ गया इनिशियल स्ट्रेस, इनिशियल प्री स्ट्रेस. इनिशियली आपका इतना प्री स्ट्रेस था, आपका एरिया ऑफ स्टील कितना आया बताएंगे? प्लीज टेल व्हाट इज द एरिया ऑफ स्टील. बोलो कितना आ रहा है? 307.87. Others also please contribute. Yes, 307.8 around I am getting. So let us take it 307.9 suppose. We can do rounding up. 307.9 mm square. Nice. मजा आ गया. Very good. Let us go to the next thing. That is pre-stressing force. Pre-stressing force कितना लगेगा? Simply sigma s into as. Yes. Simply sigma s into as. बढ़िया है, आराम है, मस्त. Sigma s कितना है? What is sigma s? How much is sigma s? Sigma s you are getting how much? It was 1100. And this area we got is 307.9, na? 9, yeah. Now you see this is Newton per mm square and this is mm square. So I'll get the answer in Newton. So I'll divide by 10 to the power 3 to get the answer in kilonewton. So what is the pre-stressing force? What is the pre-stressing force? Ladies and gentlemen, please tell me. एरिया ऑफ स्टील निकाल लिया, उसको स्ट्रेस इन स्टील से मल्टीप्लाई कर लिया, प्री स्ट्रेसिंग फोर्स मिल गया. कितना आ रहा है बताएंगे? निकाल के बताइए जल्दी से. वी आर गेटिंग 338.7 किलो न्यूटन. यस, 7 किलो न्यूटन. अब अगर हमें निकालना है लॉस इन प्री स्ट्रेस, अगर हमें निकालना है लॉस इन प्री स्ट्रेस, फॉर्मूला क्या है? वो है m इंटू एफ सी. यस, देखिए m दिया हुआ है. मॉडुलर रेशियो इज गिवन टू यू इन द क्वेश्चन. मॉडुलर रेशियो इज गिवन टू इन द क्वेश्चन. सो नेक्स्ट स्टेप इज व्हाट? टू फाइंड आउट द एफसी. एफसी फॉर्मूला इज वेरी सिंपल. एफसी इज p by a प्लस pe स्क्वायर अपॉन i. pe स्क्वायर अपॉन i, राइट? सो क्या हो जाएगा देखेंगे. p कितना है? p है 338.7. see, this stress I have to find in Newton per mm square. So I'll take all the forces in Newton and the area in mm square. So what will happen? You see, इसको मल्टीप्लाई कर 3 मल्टीप्लाई कर दिया, क्योंकि हमने किलोमीटर में निकाला था, उसको कन्वर्ट कर दिया किसमें? न्यूटन में कन्वर्ट कर दिया. वी कन्वर्टेड इनटू न्यूटन, राइट? नाउ डिवाइड बाय एरिया. एरिया ऑफ व्हाट? एरिया ऑफ कंक्रीट हियर. एरिया ऑफ कंक्रीट. तो सी द होल बीम, राइट? Area of concrete 150 into 300. There don't take area of steel. Here area of concrete. So 150 into 300 and P is 338.7. 10 to the power 3. Why? Because I have to convert into what? Into Newton. Into how much? Into your 50 square, because E is 50 we have got, right? Divided by what is this I? It is BD cube by 12 na. So 150 into 300 cube. Now divide by 12. So this 12 will go up. Okay. So I can multiply 12 here, right? Now tell me what is this FC you are getting, ladies and gentlemen. How much FC you are getting? Please tell me. Calculate this and tell me the value of FC. Okay. Ladies and gentlemen, we are going to start very serious studies for your upcoming GATE and ESE examination. So if you are serious about scoring a good rank in the upcoming examinations, so कृपया थोड़ा सीरियस होकर पढ़ाई करें, ठीक है ना? थोड़ा सीरियस होकर पढ़ाई करें. यस, तो आपके गेट एग्जाम में ऐसे ही सवाल आने वाले हैं. You're preparing for GATE examination, preparing for any examination, there will be such questions, and it's important that you cover the topic thoroughly and systematically and don't just do gimmicks. ठीक है, गिमिक्स से दूर रहिए, गिमिक्स से दूर रहिए. कितना आ रहा है? 10.03. वेरी गुड, ब्रिलियंट. The answer is 10.03, but this is what? FC. This is your FC. So what I need? I need to find out the loss. Yes? Loss कैसे निकालेंगे? M into FC कर देंगे. Very good, समृद्धि. तो क्या करेंगे? We'll find out the loss. Loss is M into FC. This we got is FC only. This we got is what? FC only. So M into FC. M कितना है? 6.66 था. और FC कर देंगे. FC कितना है? 10.03 है. बढ़िया है. कितना आ रहा है बताएंगे? लॉस इन प्री-स्ट्रेस कितना आ रहा है? चलो बताओ जल्दी से. टेल मी हाउ मच यू आर गेटिंग M into FC. देखो बहुत ही बेसिक क्वेश्चन है और यही आता है और ऐसे ही पढ़ना पड़ेगा. आपको ऐसे ही पढ़ाई करनी पड़ेगी. गिमिक्स से कुछ नहीं होगा, ठीक है ना? गिमिक्स में नहीं जाना है, ठीक है? कुछ भी आसान नहीं है, बट हाँ डिफिकल्ट भी नहीं है अगर आप सिस्टमेटिकली पढ़ते हो तो. बट सिस्टमेटिक पढ़ना पड़ेगा. 66.8 कितना है ये 66.8 न्यूटन पर mm स्क्वायर। ये 66.8 न्यूटन पर mm स्क्वायर। थोड़ा इसमें एक स्लाइड ऐड कर देते हैं, हमारे पास थोड़ा स्लाइड कम पड़ गया, तो हम क्या करेंगे, हम इसमें एक स्लाइड ऐड कर देंगे, न्यू स्लाइड कर देंगे, ठीक है, और फिर वापस अपने क्लास में आ जाएंगे। तो अभी तक हमने क्या किया है, हमने क्या किया, देखो सबसे पहले फर्स्ट ऑफ ऑल यू हैव टू फाइंड आउट एफसी। हाउ वी फाउंड आउट एफसी? पी बाई ए प्लस पी ई स्क्वायर बाई आई। और पी कैसे निकाला हम लोगों ने, इनिशियल स्ट्रेस जितना था इंटू कर दिया एरिया ऑफ स्टील, राइट। इससे हमें क्या मिल गया था, प्री स्ट्रेसिंग फोर्स मिल गया था, यस। और फिर हमने एम इंटू एफ सी करके लॉस निकाल लिया। हमने क्या निकाल लिया, लॉस इन प्रेस्ट्रेस ड्यू टू इलास्टिक शॉर्टनिंग निकाल दिया, बढ़िया है। लेकिन पूछा क्या है, व्हाट इज आस्क्ड इन द क्वेश्चन? द क्वेश्चन आस्क्ड इज फाइंड द परसेंटेज लॉस। परसेंटेज लॉस, परसेंटेज लॉस क्या होगा, देखो परसेंटेज लॉस कितना होगा, देखो लॉस हुआ कितना, लॉस वी गॉट इज 66.8 एम्पियर, राइट। हमको लॉस कितना मिला, 66.8 एम्पियर, और आई कैन से 66.8 न्यूटन पर mm स्क्वायर। तो ये क्या हो गया, लॉस डिवाइडेड बाय क्या, इनिशियल स्ट्रेस इनटू 100। यही क्या देगा, यही आपको लॉस परसेंटेज देगा, यस। सो दिस फॉर्मूला m into fc gives us the loss in pre-stress. This gives us the loss in pre-stress, but if you want to find out the percentage loss, तो क्या करना पड़ेगा भाई और बहन दोनों, तो percentage loss, if you want to find out the percentage loss, what you have to do, you have to find out the loss as we found out, divide by what, initial stress, और initial stress कितना था, initial stress कितना था, what was the initial stress, the initial stress was 1100, right, initial stress was 1100। तो क्या हो गया भाई, देखो लॉस हो गया तुम्हारा 66.8, इनिशियल स्ट्रेस वाज 1100 into 100, so what is the loss percentage you got, what is the loss percentage you got, tell me, what is the loss percentage you got, tell me, very easy question, but yes, repeatedly asked in many examination, repeatedly they ask in many examination. So what is the loss percentage you are getting, calculate and give me, 6.07%. Now suppose I am asking you what is the final pre-stressing, what is the final pre-stress, what is the final pre-stress in Newton per mm square, can somebody give me, what is the final pre-stress? It is not asked in the question, एग्जाम में नहीं पूछा है, सवाल में नहीं पूछा है, सवाल में तो परसेंटेज पे था, परसेंटेज निकाल लिया, बढ़िया है, मजा आ गया। अगर मैं आपको पूछूं कि फाइनल प्री-स्ट्रेस कितना आ रहा है, तो आंसर क्या होगा बताएंगे, फाइनल प्री-स्ट्रेस कितना आ रहा है, अगर आपको पूछ रहा हूं तो कितना आंसर होगा बताओ, what will be the final pre-stress? I will just switch on the AC for some time, it is little hot here in Bangalore. Okay, tell me what is the final pre-stress value, how will you find out the final pre-stress value, very easy, it will be initial pre-stress minus the loss it will be the initial pre-stress, आपका जो इनिशियल प्री-स्ट्रेस होगा उसमें क्या कर देंगे, माइनस लॉस कर देंगे, क्या कर देंगे, माइनस लॉस कर देंगे, निकल गया, यस। सो द फाइनल प्री-स्ट्रेस कितना आएगा बताएंगे, इफ आई आस्क यू द फाइनल प्री-स्ट्रेस, इनिशियल आपका 1100 था, 1100 बोल सकते हैं हिंदी में बोलेंगे तो 1100, एंड वी सब्ट्रैक्टेड व्हाट, वी सब्ट्रैक्टेड द लॉस दैट इज 66.8, सो आई एम गेटिंग हाउ मच, I'm getting 1033.2. Very good, very good, easy, easy. Now you solve a question for me. Now आप एक सवाल सॉल्व करेंगे, ये गेट 2017 में 2 नंबर का क्वेश्चन आया था, yes, it's a 2 mark question, okay. What is asked? The question asked is loss of pre-stressing force due to elastic deformation. क्या पूछा है आपका, देखो प्री स्ट्रेस लॉस फॉर्मूला क्या था, जो हमने प्री स्ट्रेस लॉस पढ़ा, हमने जो प्री स्ट्रेस लॉस पढ़ा वो क्या था, वो सिर्फ m इंटू एफ सी था, बट ये आंसर स्ट्रेस में था, सो दिस आंसर वाज इन स्ट्रेस, सो न्यूटन पर mm स्क्वायर, इट वाज न्यूटन पर mm स्क्वायर, दिस वाज प्री स्ट्रेस लॉस। बट इफ आई आस्क यू द प्री स्ट्रेसिंग फोर्स लॉस, व्हाट यू विल डू, टेल मी, if I ask you the pre-stressing force loss, then what you will do, tell me, if I ask you कि आपको pre-stressing force में कितना लॉस आया है निकालना है, तो क्या करोगे बताओ, इफ आई आस्क यू टू फाइंड आउट द प्री स्ट्रेसिंग फोर्स लॉस, तो क्या करोगे बताओ? चलो बताओ, जल्दी बताओ, बताओ क्या करोगे? इफ आई आस्क यू फाइंड आउट द प्री स्ट्रेसिंग फोर्स लॉस, व्हाट यू विल डू? यस, यू हैव टू मल्टीप्लाई द एरिया। ये आपका आ गया स्ट्रेस लॉस, इसमें मल्टीप्लाई कर दोगे एरिया। बट कौन सा एरिया? विच एरिया? टेंडन एरिया, टेंडन स्टील का एरिया या कंक्रीट का एरिया? स्टील का एरिया मल्टीप्लाई करना है या कंक्रीट का एरिया मल्टीप्लाई करना है? सवाल ये है, बताएंगे? प्लीज टेल मी दैट यू हैव टू मल्टीप्लाई द स्टील एरिया और द कंक्रीट एरिया। कौन सा एरिया मल्टीप्लाई करना होगा? बताइए, बताओ बताओ, कौन सा एरिया मल्टीप्लाई करना होगा? स्टील का एरिया या कंक्रीट का एरिया? Yes, you have to multiply the steel area because all these losses are happening where? In the steel or tendon or cable or wire. इसीलिए इसमें आपको मल्टीप्लाई करना पड़ेगा स्टील का एरिया। ओके, वेरी गुड देन। तो ये सवाल आप खुद सॉल्व करेंगे। आई एम गिविंग यू नाउ टाइम, यू हैव टू सॉल्व दिस। आई विल टेक अ ब्रेक बाय दैट टाइम, सो प्लीज सॉल्व दिस क्वेश्चन। ओके, चलो सॉल्व करो, फर्स्ट पास करो। I will give you time till 17:40. Okay, solve this and give me the answer. Okay, molar ratio is given, everything is given, you solve this. Okay, solve this. Yeah, I'm not visible, na? Now I became visible. Okay, so have you solved this question by this time? 4.8 kilonewton. That's correct. Very good. 4800 Newton. Okay, in kilonewton it is 4.8. Very good. Very good. Nice. Let us solve this then. Let us solve this question. Okay. Let us solve this question. Okay. Now, let us solve this question. Now, the pre-stress loss is M into Fc. Okay. Now, what is Fc? We know the formula for Fc. Fc is P by A plus P square by I. Now, as per the question, let us see. As per the question, what is the eccentricity? The eccentricity is 50 mm only, right? It is same as the previous question, right? This is your concrete beam, right? This is your concrete beam, right? 150 into 300, right? It is given that the tendon is at eccentricity, or I can say not eccentricity, it is given a distance of 100 mm from soffit. So I can say the eccentricity here is how much? It is still 50 mm. It is still what? 50 mm. Very nice. So this much was fine. This much is fine. Okay, so E we got. Now what's the P? P is how much? P I can say is initial stress into area of tendons. Now how in the tendon has 3 wires? You see, here the tendon has 3 wires. It has 3 wires, right? 1, 2, 3, and each having an area of 50. So total area will be how much? 150, na? Total area will be 150. The stress is 1200, right? So I can say what will be P? The P will be 1200 into 150 divided by 10 to the power 3. I am getting how much? I am getting a value of how much? I am getting a value of 180 kilonewton. It is how much? P I am getting is 180 kilonewton, right? Yes. I am getting 180 kilonewton. Yes. Now I can easily find out Fc. Fc is what? 180 kilonewton. I'll convert into Newton. 10 to the power 3 divided by area of concrete. So 150 into 300 plus P is how much? 180 into 10 to the power 3 E square. So 50 square divided by what? Divided by here. This is what? I. So 150 into 300 cube, BD cube by 12. Same formula. Same formula. Yes. So Fc how much I am getting? Tell me. What is the value of Fc you are getting? Tell me. What is the value of Fc you are getting? What is the value of Fc you are getting? 5.33. You are getting Fc value of 5.33 Newton per mm square. So what is this loss then? See, molar ratio is given how much? It's given 6. So 6 into Fc, 5.33. Yes, 6 into Fc, that is 5.3. So getting how much this value? 16 by 3. So getting 16 by 3, 32 Newton per mm square, right? You're getting 32 Newton per mm square. Yes. So this is the loss of stress. Pre-stress loss or loss of stress. So what is the loss of pre-stressing force? What is the loss of pre-stressing force? You see, the loss of pre-stressing force will be the loss in stress into area of tendon, which is how much? 150 mm square. So you see, this loss of stress is Newton per mm square, and this is also mm square. So whatever answer I'll get, that will get in Newton. I'll get in what? Newton. So in kilonewton it will be how much? 4.8 kilonewton. Understood? So very straightforward thing. You see 2 mark question in GATE, right? 2 mark question in GATE. But yes, if you don't know the basic things, अगर basic thing नहीं पता है तो गड़बड़ हो जाएगा. Basics नहीं पता है तो गड़बड़ हो जाएगा, और गड़बड़ होता भी है. गड़बड़ होता भी है. Okay? गड़बड़ होता भी है अगर आपको बेसिक चीज नहीं पता है तो, right? Now many students tell that, many students tell me, sir, I am preparing for ESE. What should I do? Sir, I am preparing for GATE. What should I do? I am preparing for SSC JU. What should I do? You have to study the same thing. Yes. So you're preparing for ESE or GATE or SSC JEE, you have to prepare the same. Even you're preparing for civil service optional paper in civil engineering, you have to prepare the same, because the civil engineering don't change. If you are preparing for GATE exam or ESE exam, or ऐसा नहीं कि GATE में अलग कुछ civil engineering आता है, SSC JEE में कुछ अलग आता है, ESE में कुछ अलग आता है, सेम आता है, पढ़ना सेम है, क्वेश्चंस भी सेम आते हैं, देख सकते हैं. देखिए, first we solved this question. This was I can say the class note question. Now people tell, sir, I have solved my class notes, what else I need to solve? You just need to solve previous year question, nothing else. So this I can say sort of, this was what? This was a class notes question. Yes, so class notes, this was class notes, right? Now you see previous year question, we solved one question. You see, solved one question, it is same as that of what? Class notes. Now I will give you another question. You see, this is what? UPSC Civil Service Examination 12 mark question. Yes, it's a Civil Service Examination 12 mark question. You can see the question is same. Yes, the question is same. A pre-tension concrete beam, a rectangular cross section, this much wide, this much deep. Yes, pre-stressing force is given here. Directly force they have given. Eccentricity also they have given. So they have made the life little bit easy here. Yes. Now what they have asked? The calculate the percentage loss due to elastic shortening of concrete. You see here EC and ES is given. They have not given modular ratio, but they have given data. So from that I can find out the modular ratio. It is what? ES by EC. How much that is? 210 by 35. Right? If you solve this, how much you will get? You will get, if I divide by 7, it will be 30. It will be 5. I am getting how much? 6, huh? 6 we are getting now. 6 na? Yes. So modular ratio is 6 given, indirectly given. Now rest of the things you can do, right? You see area of steel is also given. Area of steel is given, right? Your pre-stressing force is given, right? Eccentricity is given. You see the same question just asked in a different manner. Just asked in a different manner. वही same question को घुमा फिरा के पूछ लिया है. Yes, और ये आपका होमवर्क है. इसका होमवर्क करके, इसको करके कमेंट सेक्शन में आंसर लिखेंगे. ठीक है, इसको करके क्या करेंगे? कमेंट सेक्शन में आंसर लिखेंगे. कमेंट इन एंड आंसर इन कमेंट सेक्शन. अभी मत करो, हाँ अभी मत करो इसको, ठीक है? डोंट डू नाउ, डू इट एज होमवर्क. आंसर इन कमेंट सेक्शन. बट व्हाट वी आर अंडरस्टैंडिंग, क्या समझ में आया आपको? हाँ, क्या समझ में आ रहा है देख के? ये क्या समझ में आ रहा है आपको देख के? ये समझ में आ रहा है कि आपको पढ़ाई सेम करनी है, पढ़ना तो सेम है. यस, और धीरे धीरे होले होले पढ़ाई करनी है. ऐसे हड़बड़ी नहीं पढ़ना है, ठीक है ना? चिल्ला चिल्ला के नहीं पढ़ना है. कोई इमोशन विमोशन नहीं है, कुछ नहीं है. पढ़ाई है सिंपल. इट्स सिंपल स्टडीज. एट द एंड इट इज स्टडीज ओनली विच इज गोइंग टू मेक यू क्लियर द एग्जामिनेशन. नो रिवोल्यूशन, नो इमोशन, नथिंग विल हेल्प यू. यस, सो यू हैव टू स्टडी. ऐसे सीरियस होकर आपको पढ़ाई करना है. अब देखिए एक छोटा सा टॉपिक, देखिए एक आरसीसी का प्री स्ट्रेस, ठीक है? आरसीसी का प्री स्ट्रेस, उसका प्री स्ट्रेस लॉस का एक टाइप में, उसको समझने के लिए भी आपको सिस्टमैटिकली पढ़ना पड़ता है. और आपको लगता है कि आप ऐसे पूरा गेट का सिलेबस, पूरा ईएससी ऐसे नाच कूद करके यहाँ वहाँ से पढ़ लेंगे. अगर आपको ऐसा लगता है तो आप क्या हैं? आप गलतफहमी में हैं, आप सपने में हैं. वो सपने से निकलिए, रियल वर्ल्ड में आइए. यस, कम टू रियल वर्ल्ड एंड कम टू रियल वर्ल्ड विद सत्यजीत साहू. इफ यू आर नॉट yourself coming into the real world, you can attend my classes. If you attend my classes, you will come back to reality. आपको रियलिटी हिट करेगा, आपको समझ में आएगा, अरे बाप रे ऐसे नहीं होता है, पढ़ना पड़ेगा. पढ़ना पड़ेगा, to study seriously. But again, as I told, you are preparing for GATE, you are preparing for ESE, you are preparing for SSC JEE. This will be same thing. You have to study in the same manner. Yes, पहले आपको कॉन्सेप्ट को समझना है, फॉर्मूला समझना है, जैसे पहले हमने समझा. Yes, फिर उसके बाद आपको क्लास नोट्स के सवाल करने हैं, जैसे हमने सॉल्व किया. Yes, उसके बाद you have to solve your previous year question. And when we solve the previous year question, we saw that they are more or less what? Same. They are more or less what? Same. अब थोड़ा और समझते हैं, चीज़ों को और समझते हैं, ठीक है? तो हमारे पास थोड़ा स्लाइड कम है, तो हम क्या करेंगे, इसमें एक स्लाइड ऐड कर देंगे. हम इसमें एक स्लाइड ऐड करेंगे, फिर हम उसमें और एक स्लाइड ऐड कर देंगे. 2 स्लाइड ऐड कर दिया, ठीक है। चलो वापस इसमें आ जाते हैं। तो हमने अभी तक क्या पढ़ा है, व्हाट वी हैव स्टडीड टिल नाउ। यू सी दिस इज अ बीम, yes, this is a beam, yes, yes, और आपका यहाँ पे प्री टेंशनिंग हो रहा है, ठीक है ना, प्री टेंशनिंग हो रहा है, बढ़िया है, यस। तो आपने क्या किया, एफसी कैसे निकाला, एफसी आपने निकाला पी बाई ए प्लस पी स्क्वायर बाई आई करके निकाल लिया, बढ़िया है। इसमें ई क्या है, ई आपका ये था, eccentricity, this was your E, yes, and A and I were the area and I of the concrete section। वो तो पता है आपको कैसे निकालना है, area will be B into D and I will be BD cube by 12, and prestressing force also we know how to find out। Now this is only when tendoning is this pre-tensioning is done at one location, एक ही टेंडन है, हो सकता है कि 2 टेंडन हो और सेम लोकेशन पे ना हो, यस हो सकता है ना, यस हो सकता है। मान लीजिए कि आपका, let us have a case where you have such a case, you see this is one tendon, okay, this a beam is same, but आपका एक टेंडन यहाँ पे है एंड और एक टेंडन यहाँ, अरे मैं कहीं गया ही नहीं था, सब कम बैक बोल रहे हैं, आई वॉज देयर ओनली, आई वॉज हैविंग अ वैकेशन, आई वेंट फॉर एन वैकेशन, ओके। So the vacation is over, now serious studies will take over. So now you see, if there is 2 locations, you see tendoning or pre-tensioning is happening at 2 locations, क्या करेंगे, तो इसमें क्या होगा, देखो इसमें 2 eccentricity आ जाएगा। You see this is your E1, here 2 eccentricities will come into picture, you see E1, आराम से पढ़ेंगे, हौले हौले आराम से पढ़ाई करेंगे, ठीक है, इंजीनियरिंग पढ़ रहे हैं, ठीक है ना, तो we are studying engineering, so we will study very calm and quiet, okay। So this is E1 and this is what, this is your E2, this is your E2, there are 2 eccentricities, there are 2 eccentricities. Similarly here there will be A1, there will be A2, 2 areas will also come into picture, yes। So in this case what we will do, we will have the concept of effective eccentricity. So all the tendon will be concentrated at one place. We have the concept of what? Effective eccentricity, and this effective eccentricity is sort of what? This effective eccentricity is sort of what? It is sort of the centroid of these tendons. Now centroid कैसे निकालते थे, याद है? How we are finding centroid? Remember, of 2 areas of a complex area, C1A1 plus C2A2 by A1 plus A2. So similarly here, this effective eccentricity E also will be equal to how much? It will be your E1A1 plus E2A2 divided by what? A1 plus A2. A1 plus A2. A1 plus A2. Yes, A1 plus A2. Now what happens is that here it's a tendon, like this. Here also it is tendon, yes. In this tendon normally what happens, the diameter of the wire is same. Diameter of wire is same. What will vary is the number of wires. What will vary is the number of wires. How? Suppose here there will be 3 wires. Here there will be what? 5 wires or 6 wires or 7 wires, whatever. Just a number I am giving. Right? The diameter is same. So here diameter is same, here also diameter is same. Right? But the number of wires are different. Here suppose the number of wires is N1. Here the number of wires is N2. The number of wires is what? N2. Number of wires is different. Now if diameter is same and number of wires is different, area will be different now. Yes. But can I say that what will be this A1? This A1 will be, you see, N1 into pi by 4 d square na. And what will be this A2? This A2 will be N2 into pi by 4 d square. Yes, similarly this A2 also will be N2 into pi by 4 into d square, and this A1 will be equal to N1 into pi by 4 into d square. Yes, क्या हो रहा है? What is happening? You can see that from both numerator and denominator this pi by d square, pi by d square, pi by d square, pi by d square will get cancelled, and this effective eccentricity, how much I will get? I will get simply E1N1 plus E2N2 divided by what? N1 plus N2. Easy. E1N1 plus E2N2 by N1 plus N2. Easy. Because the diameter is same, diameter of wires inside the tendon will be same, just the number of wires will be different. That's it. Yes. So in this case we got this. Now when you're finding the loss in tendon 1, when you're finding the loss in tendon 1, what you will do? That will be equal to M into FC, same formula, M into FC only, tendon 1 means this location. Formula will be same, but what will vary? This FC will be equal to what? This FC will be equal to P by A only, P by A only, then P by I also, but in place of E square, it will be what? E into E1. And then when you're finding the loss in tendon 2, that will be what? M into FC, and here FC will be equal to what? Here FC will be equal to P by A plus what? Your PE E2 by I. Understood? PE E2 by I. Got it? Got it? Yes? So PE E2 by I. So this only varies when you have tendoning at two places, or okay, so tensioning at two locations. Tensioning at two locations, what we are doing? We are changing this. It becomes E1, E2. Normally it is E square, because if there is one location, then E1, see, if there is one location, then E1 is equal to E2 is equal to E only, na? Yes, it will be E1 is equal to E2 is equal to E only, na? And therefore what is happening? E square. But here it will be not E square, it will be E into E1 for tendon 1 and E into E2 for tendon 2. That's it. Let us solve one question then. Let us solve one question. Very good. Let us solve one question. Big question, you see. A pre-tensioned concrete beam of rectangular cross section 200 mm wide and 300 mm deep. Okay. So this is your width. The width is how much? The width is 200 mm and your depth is 300 mm. Okay, depth is 300 mm given here. And you see what is given? It is given that is pre-stressed by 15 numbers. See, 15 5 mm means what? The diameter is 5 mm but number is 15. So 15 5 mm diameter wires located at 65 mm from soffit. You see, 65 mm from soffit. Yes. So I can say this is the location 1. Yes. And here, how many wires are there? Can I say N1 is equal to how much? 15, na? 15 wires are there in this tendon, right? From soffit and how much? 65. The other one is what? 3 5 mm. At location 3, here N2, how many wires are there? 3 wires. You see, 3 5 mm dia wires. So diameter is 5 mm, but the numbers are varying in each tendon. Very nice. Located how much? It located at 25 mm from top. Look at how much? 25 mm from top. Ladies and gentlemen. Hi, Bamsi Krishna. Yes. Ladies and gentlemen, dear ladies and gentlemen. Dear ladies and gentlemen, can you tell me, क्या आप हमें बता सकते हैं कि E1, E2 का वैल्यू कितना होगा? From the diagram, ladies and gentlemen, tell me what will be the value of E1 and E2. Ladies and gentlemen, बताएंगे कि E1 और E2 कितना आएगा? E1 और E2 कितना आएगा बताएंगे. What will be the value of E1 and E2 from the diagram given? What is E1 and E2? Please tell me. E1 is 85, okay, and what is E2, ladies and gentlemen? E2 is minus 125. देखो ये तो कोई डाउट नहीं है कि ये वैल्यू कितना आएगा. There is no doubt in that this value will be 85. Why? Very simple. Total depth is 300. So obviously this will be how much? This will be how much? 150. So 150 minus this will be this. Now here there will be concept of what? Sign convention. What is sign convention? You see, below the neutral axis we are taking the eccentricity as positive. So above the neutral axis we'll take how much? We'll take this as negative. We'll take this as negative, and this value will be how much? Minus 125 mm. This value will be how much? Minus. This is plus 85. Okay. And this is minus 125. Yes. Plus 85, and this is how much? Minus 125. समझ में आया सबको? समझ में आया? Yes. Again I will repeat. Yes. That here we are taking positive below the neutral axis. Below neutral axis we are taking positive. So above the neutral axis I will take what? I will take as negative. I will take as negative. Always follow this. Otherwise you will get wrong answers. Yes. Below the neutral axis if you are taking positive, above you will take it as negative. Now can you give me the effective eccentricity? Can you give me the effective eccentricity? We have the number of wires here, right? The number will be positive only. Don't take it negative. So can you give me the effective eccentricity here? Taking what? E1 N1 plus E2 N2 divided by what? N1 plus N2. So what is the effective eccentricity you are getting from this formula? Ladies and gentlemen, please tell me. What is the effective eccentricity you are getting from this formula? Tell me. Good. Very good. You are getting how much? You see, 85 into 15. Then we have a minus sign. 125 into 3 divided by what? Total number of is 18, right? N1 plus N2. You are getting how much? Getting a value of 50 mm. You are getting E as how much? You are getting E as 50 mm. Yes, I got E as 50 mm. Very good. So when I am finding loss in tendon 1, when I am finding the loss in tendon 1, so what I will do? I'll use the FC formula as what? P by A. I'll use the FC formula as what? I'll use it as P by A plus PE square upon I. PE square upon I. Very good, very good, very good. PE square upon I. Right? Now what is the P? P is sigma S into AS. Now in this area of steel, I will take all the tendons. I'll take all the tendons. Total how many? All them is all the wires. Total how many wires are there? 18 wires are there, na? And each wire is having how much diameter? Each wire is having diameter of 5. Total 18 are there, na? You see, 15 plus 5. Total 18 are there, right? 15 plus 3. Sorry. Total 18 are there. And what is the initial pre-stress? Initial pre-stress is given 840. It's given how much? 840. The pre-stressing force is 840 into AS is how much? Whatever you are getting this value, divided by 10 to the power 3 and give me the pre-stressing force. Because when you are finding the pre-stressing force, it has to be total pre-stressing force. So how much you are getting? Tell me. How much you are getting? Tell me. चलो बताओ 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 कितना आ रहा है? How much you are getting, ladies and gentlemen? P force. $296.88. Very good. I am getting 296.88 kilonewton. बढ़िया है. 296.88 kilonewton. बहुत बढ़िया है. बढ़िया नहीं है. बहुत बढ़िया है. Yes. Because it is total one you will find out. Now you can easily find out the FC here. It will be what? 296.88. I'll convert into Newton. Okay. Then divide by area. Area is how much? 150 into 300. 200 into 300. Width and depth. Yes. 200 into 300. Very good. Plus P is 296.88 into 10 to the power 3. But no, we have written the formula wrong. It should not be E square. It will be what? E into E1 now, because tendon 1. Tendon 1, E into E1. Yes. So E is 50 and E1 is 85. That divided by what? I. I is a rectangle. It's a rectangle. So what I will do? It's a rectangle. So BD cube upon 12. So this 12 will come up here, right? So tell me what is the FC you are getting here? Yes, 50 into 85. This is your effective eccentricity and this is the eccentricity of tendon 1. Why? Because I am finding the loss in tendon 1. Because I am finding the loss in tendon 1. Because I am finding the loss in tendon 1. Finding the loss in tendon 1. Must. Getting how much? 7.75. Brilliant. 7.75 Newton per mm square. So this is FC for tendon 1. So what is the pre-stress loss? What is the pre-stress loss? You have to multiply what? Simply modular ratio. And modular ratio is given how much? It is given 6. So 6 into 7.75. So what is the loss of pre-stress in tendon 1? How much are you getting? Tell me. Value, very easy, just multiply 6, 46.5 or 40, 42, 46.5. Ah, 46.5. I'm getting how much? 46.5 Newton per mm square. Nice. Badhiya. Badhiya. Yes, easy. Now similarly, if I want to find out loss of pre-stress, in tendon 2, what I will do? Here FC will be same formula. P by A plus what? PE into E2 by I. Yes, here in place of E1 I will use what? E2. Same formula. Now what I will do? This will be pre-stressing force will be same. That will not change. The total pre-stressing force. So this 10 to the power 3 divided by area of concrete won't change. That will be 200 into 300, right? Then P force again will be same. 296.88 in 10 to the power 3. Yes, because I converted Newton. See, E was 50. But what about E2? It was minus 125, right? So what happens? This minus sign will come here. Yes. There is a minor change, right? It is minus 125. So that minus sign will come here. And this will be 200 into 300 cube divided by 12. So 12 will go here. So how much is, ladies and gentlemen, this FC? The FC for tendon 2. The FC for tendon 2. How much you are getting? FC for tendon 2. What is the FC for tendon 2? Please, ladies and gentlemen, give me this value. Give me this value. I am waiting. Point 0.824, very good. 0.824 Newton per mm square. You can see you are getting less value. Why? Because this negative sign was, the negative sign tha na, to kam ho gaya. So what is the loss? What is the pre-stress loss? What is the pre-stress loss? The pre-stress loss is equal to how much? 6 into 8 to 4, that is how much? If I multiply, how much I getting? 4 point something, na? We'll get 4.95 something, I think. 4.495, almost 0.5. How are you getting this? Almost 4.95 Newton per mm square. So let us revise what we have studied today. Let us revise what we have studied today. Okay. So today we saw, okay, the laws of prestress. The laws of prestress. The laws of prestress due to elastic shortening. Due to what? Due to elastic shortening. Okay, due to what? Elastic shortening. Badhiya hai? Yes. Now, whatever formula you saw, yes, whatever formula you saw, that was only for pre-tensioned beams. That is only for what? Pre-tensioned beams. Okay, that is only for what? Pre-tensioned beams. So in pre-tensioned beam, if there was a single tendon, yes, we saw for single tendon, the loss was how much? The loss was m into fc. And what was this fc? fc क्या था? p by a plus p square by I था. और अगर 2 टेंडन से तो क्या करेंगे? yes, अगर 2 टेंडन से या मल्टी टेंडन से, 3 टेंडन है, 4 टेंडन है, फॉर्मूला क्या होगा? किसी भी एक टेंडन के लिए m into fc ही रहेगा. The m into fc formula will be same, only what will be fc? fc will be p by a plus pe into what? Your e1 by I. If you are finding in tendon 1, yes, or I can generalize it as what? Ith tendon, right? Ith tendon. If there are 3, then E3. If there are 4, E4, yes. Or I can say that what will be the effective eccentricity? Can I say this is summation of EI, AI by summation of AI, and I told that the area depends on number of tendons. So can I say it is summation of Ni? Yes. If there are 2 tendons, if only there are 2 tendons, I'll write down as a multi-tendon. Suppose I'm writing this as what? Multi-tendon. So if there are 2 tendons, then what will happen? If there are 2 tendons, what will happen? If there are 2 tendons, it will be E1 N1 plus E2 N2 by N1 plus N2. If there are 3 tendons, then E3 N3 plus N3. If there are 4 tendons, like this continues, right? And then whichever tendon you are finding the loss, you will use that eccentricity here. If I am finding in the first tendon, then E1. I am finding in the second tendon, then what? E2. I can say in multi-tendon, this is what? The formula for loss in ith tendon. Loss in ith tendon. Yes, loss in ith tendon, right? Understood? So today we only discussed for single tendon and multi-tendon for your pre-tensioned beams. Single tendon and multi-tendon for your pre-tensioned beams. There is something known as what? Post-tension beams. Something known as what? Post-tension beams. Yes. Something known as what? Post-tension beam. Now what happens in the post-tension beams? What happens in the post-tension beams? Yes. I'll tell you, don't worry. How to study that I'll tell you. And till now, whatever tendons we saw, that was straight tendon, right? We're seeing all straight tendon. These are also straight tendon. There can be curved tendon also, right? There can be curved tendon, also curved cables. You see, this is what? This is what? This is a straight tendon, right? Right? And this is what? This is a curved tendon, right? This is curved tendon, right? So there can be curved tendon, there can be straight tendon. So whatever we studied till now, what we have studied? We have just studied pre-tensioned, okay, straight tendon. Yes, pre-tensioned straight tendon. So what is remaining? What is remaining? What is remaining? The remaining portion is pre-tensioned only. The remaining is pre-tensioned only. But where? In your curved cables or curved tension. Also, for post-tension beams, straight tendons, yes, and post-tension beams, you're curved. Understood? So today we covered only this portion, but it's an important portion. Yes, certainly I can say 25% of this, right? We have covered 4 topics. Yes, in this we have covered 25% at least. Yes, we tried to cover some important portion. Yes, but we cannot cover everything on YouTube. Yes, everything should not be completed like this. Yes, so if you want to understand all the remaining concepts of only this topic of pre-stress loss in your elastic shortening case, then all these things I have recorded. Yes, all these things are present. If you go to the BYJU'S exam prep app, okay, download it. If you have not downloaded it, download it. There you can find this all learn with video lessons. There you can go to design of concrete structures. Yes, when you click on this, what will happen? Then you can see all chapter wise content is available. You can see limit state design, working stress, working state method, and then design of shear, bond, torsion, slab, column, everything is there. Okay, so there when you go to design of pre-stressed concrete, there will be losses chapter, and in losses I have covered all this in details. You can see there are 3 videos. You see, elastic shortening of concrete 1, yes, elastic shortening of concrete 2, elastic shortening of concrete 3. This is only elastic shortening. I have also covered friction loss, you can see, then slip loss, creep and shrinkage loss, and there are numericals. You can see such kind of structured content is available for all of you. And if you want to excel in the examination, then you have to cover in this manner. Now many students are asking me, sir, GATE 2023 was tough. I was not able to score, and so many people are giving some weird reasons like clumsy paper or calculator not working like that. But that is not the reason. The reason is that every time GATE won't be very straightforward. Yes, the GATE is just asking what is mentioned in the syllabus. It is the student's responsibility to cover all the topics in a very systematic manner, as I told, only for this topic. Now what students do? Because in the previous year only this is asked, they will just study this portion and go. They will not cover this portion, and when this year these portions are asked, then they are not able to answer. Yes, they are unable to answer, and then you end up with 30 marks or 40 marks, and then you're asking, sir, I have to do MTech or what? No, you should go for complete syllabus coverage in a structured manner, as I am been telling you. If you feel that by covering here some bits and bytes from here and there, if you think that you are going to get a good rank, that is not going to happen. That is not going to happen. Write it down on a piece of paper. That is not going to happen. The paper was not tough, just they asked from the syllabus and from some portions which were not asked before. Doesn't make it tough. It is that you have not covered. आपने cover नहीं किया है उसको. आपने cover नहीं किया है. इसका मतलब ये नहीं है कि वो गेट में नहीं आएगा, वो सिलेबस में है. जब आपका प्री स्ट्रेस लिख दिया है तो वो सिलेबस में है. आप नहीं पढ़े हो, आपने यार प्रीवियस ईयर कर लिया, या फिर आपने किसी ऐसे टीचर से पढ़ाई किया जो सिर्फ प्रीवियस ईयर ही पढ़ा रहा है. आप क्या कर रहे हो? आप किसी ऐसे टीचर से पढ़ रहे हो जो सिर्फ प्रीवियस ईयर करा रहा है, उसको भी नहीं पता कि बाकी क्या आना है क्या नहीं आना है. वो भी प्रीवियस ईयर करवा रहा है, आप भी प्रीवियस ईयर कर रहे हो, और जब प्रीवियस ईयर छोड़ के कुछ अलग आ रहा है तो आप बोल रहे हो क्लमजी पेपर हो गया, कैलकुलेटर काम नहीं किया, लेंदी हो गया, ये हो गया, वो हो गया. नहीं, कुछ नहीं हुआ है. Nothing has happened. You have just not studied the topics in details in a structured manner. You just solve the previous year question. That is not going to help. Don't study from teachers who are teaching you only previous year. That is not the way to cover for GATE or any competitive exam. At least for GATE, I can say, if you are appearing for some imaginative examination, which many teachers are now giving you an idea of an imaginative examination. Okay, now some some teachers, what they do, if you ask them, na sir, how to study irrigation, or delta duty kar lo, ho gaya. I have seen some teachers, if you ask them, कैसे irrigation कैसे पढ़ना है सर, delta duty कर लो. And I ask some teachers, सर आरसीसी कैसे पढ़ना है, खाली बीम कर लो, बीम का खाली एमओआर निकालना सीख लो. अरे नहीं होगा ऐसे, ऐसे टीचर से पढ़ना बंद कर दो, ठीक है. So again I am going to say, therefore I am conducting this session. See, in these sessions obviously I will be unable to cover a whole syllabus, but yes, these sessions are to enlighten you how to prepare for examination. वो 10 तो strategy video बना रहा है, ठीक है ना, 10 strategy video, हाँ, पूरा साल strategy चल रहा है. Whole year you are watching strategy videos. Whole year you are strategy. 10-month preparation, 9-month preparation, 8-month preparation, 7 months, 6, 5, 4, 3, 2, 1, 1 week, and then you know again 11 months preparation, 10. ये strategy video देखना बंद कीजिए. ओके, स्ट्रेटेजी वीडियो देखना बंद कीजिए, पढ़ाई में आ जाइए. पूरा सिलेबस कंप्लीट करना होगा. इस तरीके से सिस्टमैटिक वे में यू हैव टू स्टडी. एंड इफ यू आर नॉट स्टडिंग इन दिस सिस्टमैटिक वे, योर सिलेबस विल रिमेन, and then next year when you give the paper you will feel that some questions are out of syllabus. Questions are not out of syllabus, you have not studied them. Okay, thank you very much. So all these things are covered here. Okay, so if you want to see all these videos, okay, we are conducting scholarship test for the same. Yes, so those students who want to avail the full videos and full courses, for their help we are conducting this scholarship examination. The next scholarship examination is on what? On 16th of April, means next week. Okay, next week at 12 p.m. So what you do, you download the BYJU'S exam prep app. Okay, this app is available on the Play Store, okay, on your mobile, or you can see from website also, www.byju'sexamprep.com. yes, और वहां जाके आप क्या करेंगे, you can register for this. If you register for this and then seriously give this particular scholarship examination, you can get 90% scholarship. Okay, 90% scholarship. Okay, you'll get 90% scholarship, and then you can avail all these courses. I will be teaching. I have already recorded many lectures on the this app. I have recorded, strength of metal. My strength of metal lectures are available. My fluid mechanics is available. My geotech is available. My environment is available. Okay, my open channel pool is available. Many lectures are available, and other also esteemed teachers have also covered many syllabus. Also, I am teaching their live. Also, I am taking a lot of courses like CPM, PERT, steel structures, building material, concrete structures. Okay, so please enroll for such courses and please study in this manner. This is the way to study for your GATE and ESE examination. Okay. Now tomorrow at 6 p.m. I have one important session coming up. Okay, so many students now are thinking that they are unable to study at home. Okay, due to online, due to COVID conditions. Earlier students were forced to study at home, but now many students are thinking that I am unable to study at home, so let me go to Delhi, and Delhi I will prepare for examination. So this question is hovering around the minds of many students. बहुत सारे स्टूडेंट्स के दिमाग में ये विचार आ रहा है, तो हमें जाना चाहिए कि नहीं जाना चाहिए, इसका आंसर कल आपको 6 बजे मिलेगा. So tomorrow I am going to take important session for many students. Should I go to Delhi or not for GATE and ESE preparation? That is a very burning issue now. Many students are telling, नहीं पढ़ाई नहीं हो पा रहा है घर पे, हमें दिल्ली जाना. चलो दिल्ली चलेंगे. तो दिल्ली चलना है कि नहीं चलना है, ये हम कल बताएंगे 6 बजे. Okay, and this is my contact number. This is my contact number, and this is my email ID. If you want to contact me, you can always contact me. This is my contact number. You can note down, and this is my email ID. Okay. Thank you very much. See you tomorrow at 6 p.m. That was great interacting with you.